Welcome to Astronomy Daily, the podcast where we unpack the universe one headline at a time. I'm Anna, your guide through the cosmos.
And I'm Avery, here to geek out over the latest in space and astronomy with my favorite stargazing buddy. Today is October 11, 2025, and folks, we've got a stellar lineup. From shiny new satellite factory in Italy to record-breaking investments lighting up the space economy, a geyser-like interstellar comet, the first ever snapshot of dueling black holes, and the sneaky ocean hiding under Saturn's weirdest moon. Anna, it's like the universe decided to drop a care package of wonders on our doorstep.
Absolutely, Avery. It's days like this that remind me why we do this. Pure, unfiltered awe backed by solid science. We'll dive into each story, chat about what it means, and maybe speculate a little on where it's all headed. Grab your coffee or your star chart. Let's launch right in. Kicking things off with some earthbound excitement in the space industry. Thales Alenia Space, that powerhouse joint venture between Thales and Leonardo, just inaugurated a brand new 100 million euro satellite factory in Rome. It happened on October 7th, and it's part of Italy's bigger Space Factory 4.0 push, led by the Italian Space Agency.
Yeah, I love how this ties into their National Recovery and Resilience Plan. Post-COVID funding funneled into high-tech like this. The factory's geared for micro and small sats with a capacity of over 100 per year, and it's scalable if demand spikes. They're kicking off with a Psychro 3 satellite for Italy's defense ministry, a secure comms bird that's been in the works since a $159 million contract back in 2021.
It's the third piece of this interconnected network. Argotech's microsatellite park opened last year, Saturn'S propulsion facility in March, and Sierra's lab coming in 2026. Imagine a whole ecosystem of smart factories talking to each other, cranking out sats efficiently. For Europe, this means ramping up competitiveness in a market that's exploding with small sat needs, from defense to climate monitoring.
Totally. And that PNRR funding, 49% of the program's investment, shows governments getting serious about space as an economic driver. It's not just Italy. This could inspire similar hubs elsewhere. What do you think, Anna? Will we see more nations betting big on domestic manufacturing to cut reliance on, say, US or Chinese launches?
I do. It's a hedge against supply chain hiccups. And with small sats getting cheaper and more versatile, localized production makes sense. Fingers crossed it boosts jobs, too. Space tech employs some brilliant minds. All right, shifting gears to the money flowing into all this. Speaking of betting big, global space investment just smashed records. $3.5 billion poured in during Q3 2025 alone. That's nearly double last year's haul, per Seraphim Space's report. And it's not just the usual suspects. It's spreading across startups, from rocket builders to LEO constellations, fueled by AI synergies and defense bucks.
Wild, right? Seraphim's Lucas Bishop nailed it. What we're seeing now is a far more diverse set of investable companies, signaling that space has evolved into a broader, more mature market. No longer SpaceX and OneWeb hogging the spotlight. Take China. Galactic Energy snagged $336 million in September for reusable launchers like the Pallas series and Series 2 solid rockets, plus facilities. That's industrial mobilization on steroids, as Space Capital's Chad Anderson put it. And over here in the US, Apex just raised $200 million at a $1 billion valuation for national security sats and commercial fleets, tied to the Pentagon's Golden Dome initiative for hardened space systems. Satellite manufacturing's hot. 60% of funding rounds in the last 15 years happened since 2021. Launch sectors pulled in $52.4 billion total since 2009, edging out sats at $47.7 billion. Public companies are soaring too. Rocket Lab and Planet Labs doubled. AST Space Mobile tripled after their Sataphone demos.
It's the dual-use magic, tech for defense and civilians, like Starshield or OneWeb. With governments in the US, China, and Europe pushing domestic industries, this momentum could carry into 2026. But Avery, does this maturing market worry you? Will it dilute the wild innovation we saw in the early days?
A bit, but I think diversity breeds resilience. More players mean more ideas, and with AI optimizing orbits and payloads, we're in for efficient, scalable wins. It's exciting. Space isn't niche anymore. It's the next tech frontier. Okay, enough with the bowlers. Let's get interstellar.
Oh man, this next one is straight out of sci-fi, but very real science. Interstellar Comet 3I/Atlas, our third visitor from another star, is venting water like a fire hose on full blast. NASA's Swift Observatory caught it in July and August, when the comet was 2.9 times farther from the sun than Earth. Lead researchers Zexi Zing from Auburn University and team detected hydroxyl, OH, the UV fingerprint of water vapor, losing about 40 kilograms per second.
That's at least 8% of its surface active, way higher than the 3 to 5% in our solar system's comets. But get this, it's not the nucleus sublimating directly, it's icy chunks in the coma acting like mini steam vents under sunlight. Gemini South and NASA's Infrared Telescope facility spotted those ice bits. Published September 30th in Astrophysical Journal Letters, it's our first chemical peek at water from an interstellar wanderer.
Dennis Bodwitz, Zing's co-author, said it best. When we detect water from an interstellar comet, we're reading a note from another planetary system. It tells us that the ingredients for life's chemistry are not unique to our own. Compare that to Oumuamua, which was bone dry, or Borisot, loaded with carbon monoxide. Atlas is rewriting the playbook on how these objects form around other stars.
And it's not done yet. ESA's Mars orbiter spotted it 30 million kilometers from the red planet in early October. JUICE will track it post-perihelion in November with data back in February 2026. Peak activity incoming. Implications? Water as a yardstick for comet behavior helps us model planet formation galaxy-wide. And if these chunks are venting so wildly, does that hint at more volatiles out there than we thought?
Definitely. It underscores diversity in interstellar chemistry. Not every system's comets are alike. Makes you wonder about the oceans or atmospheres they fed in their home stars. Thrilling stuff. Keeps the "are we alone" question bubbling. Now for something even heavier. Black holes.
Heavy indeed. Astronomers just nabbed the world's first radio image of two supermassive black holes orbiting each other in quasar OJ287, 5 billion light years away in Cancer. It's been predicted for decades, but this is visual proof. A pair locked in a 12-year dance, jets twisting like a garden hose.
Lead author Mauri Valtonen from the University of Turku in Finland's team used Earth telescopes plus Russia's Radio Astron satellite, RIP, it retired in 2019, for a resolution 100,000 times sharper than optical. The black holes themselves are invisible, but we see bright radio spots from their particle jets and glowing gas. Published October 9th in the Astrophysical Journal. Valtonen noted, the black holes themselves are perfectly black, but they can be detected by these particle jets or by the glowing gas surrounding the hole.
OJ287's been watched since the 1800s. Amateurs can spot it. In 1982, Aimo Sillanpää clocked that brightness cycle, hinting at binaries. Hundreds of eyes on it since, but only now do we resolve the duo sharing a galactic core. The smaller one's jet wags like a tail over the orbit, real-time evolution we can track.
Huge for validating binary formation models and quasars. We've imaged singles like Sagittarius A star or M87s, but pairs? Only indirect gravitational waves before. This tests general relativity and extreme gravity, refines merger predictions, and boosts sims of galaxy evolution. Avery, that jet wagging, does it scream accretion disk drama to you?
All day. It's like watching a cosmic tango that heats up the quasar. Could explain variability we've puzzled over for a century. Plus, it paves the way for more high-res radio hunts. Event Horizon Telescope, eat your heart out. One more moontail before we wrap.
Wrapping with Saturn's oddball moon, Mimas, the Death Star for that massive crater. Cassini data is pointing to a young subsurface ocean, 12 to 19 miles under the ice. Not ancient. It formed 10 to 15 million years ago from an eccentric orbit shift, causing tidal heating.
Scientists Alyssa Roden and Adine Denton from Southwest Research Institute modeled it, presented at last month's EPSC DPS.
Denton's paper fresh in Earth and Planetary science letters. No surface cracks like Enceladus or Europa, but libration wobbles scream liquid inside. The orbit got wonky, maybe from Saturn's system tugs, melting ice fast without resurfacing everything.
Rodin's heat flow maps show uneven thinning, prime spots for future orbiters to probe with IR. And Herschel crater? Simulations say it hit when Mimas was on the tipping point, warm but solid ice, forming that peak. Denton, Mimas needs to be right on the tipping point. It can stay on that tipping point for millions of years. Expands the ocean's age window to 10 million years. Geologically, blink of an eye.
Rodin added, when we look at Mimas, we don't see any of the things that we're accustomed to seeing in an ocean world, but the data's building a coherent narrative. Implications? Redefines icy moon timelines. Subtle orbits can brew oceans quick. Habitability hints. Maybe if we send a probe to sniff for biosignatures. And a Mimas over Enceladus for a mission. Underdog charm?
Totally. It's the sleeper hit. Proves oceans aren't just for the flashy ones. Guides Saturn explorers on where to look. What a day in the field.
That's our Cosmic Roundup for October 11th. Huge thanks to our listeners. You're the stars that keep us orbiting. If these stories sparked your curiosity, drop us a line on X or wherever you stream us.
Absolutely. Tune in next time for more Astronomy Daily. Clear skies, stay curious, keep looking up, and remember, the universe is vast, but we're all in this together. I'm Anna.
And I'm Avery. Good night, good morning, or good day, depending on where you're hearing us, Space Fam.